Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Boiling points of amines depend on their ability to form hydrogen bonds. Primary amines, RNH2, have two NH bonds and can form strong intermolecular hydrogen bonds. Secondary amines, R2NH, have one NH bond and form weaker hydrogen bonding than primary amines. Tertiary amines, R3N, have no NH bonds and cannot act as hydrogen bond donors, so they have the lowest boiling points among isomers of similar molecular weight. Moving on to the next step. Identify the class of each amine. A. 4-methylpiperidine, the nitrogen has one H attached, NH present in the ring, making it a secondary amine, can form hydrogen bonds. B. N-methylcyclopentylamine, the nitrogen has one H, NHCH3, making it a secondary amine, can form hydrogen bonds. C. 1-methylpiperidine, the nitrogen has a methyl group and is part of the piperidine ring with no NH bond, making it a tertiary amine, cannot donate hydrogen bonds. D. Cyclohexylamine, the nitrogen has two H atoms, NH2, making it a primary amine, strongest hydrogen bonding among these options. Moving on to the next step. Rank boiling points. Primary amine, D. Secondary amines, A, B. Tertiary amine, C. Tertiary amine, C. 1-methylpiperidine, has no NH bond, so it cannot form hydrogen bonds as a donor, resulting in the lowest intermolecular attractive forces and thus the lowest boiling point among these isomers. And for the final step. Why other options fail? A and B are secondary amines with one NH bond, so they have higher boiling points than the tertiary amine. D is a primary amine with two NH bonds, giving it the highest boiling point. Therefore, the correct answer is C. Therefore, the correct answer is option C.